All right. Determine if the function or sequence, if we're defining it with function notation instead of sequence notation, is linear, which would mean it's an arithmetic sequence, exponential, which would mean it would be a geometric sequence, or neither, and then tell me why. What do we see? Did anyone look at it and go, I think it's going to be this, just intrinsically it feels like it's going to be this? Yeah.
It's going to be linear because it goes for every 3 it then goes down by 5.
We recognize right away, I'm going to check differences because the numbers aren't changing drastically. Would you agree? If I had 160 and then down here by this -4 or even a +4, if I had progression like that, would I try subtraction first, or would I maybe look to see if it has a common ratio, right? So just looking at this, we're not seeing a whole lot of change between them. So my gut instinct also would be, do we see over equal length input value intervals, do we see a constant change? Did we see that? This is enough that I can say the rates of change over equal length input value intervals are constant. Remember that language, right? The over equal length input interval values, the values change. Here we said constant, at a constant rate. If you use that language, you don't need to state the common difference. That means it's linear. If we see a constant rate of change over equal length input value intervals, and we see, bless you, we see equal length input value intervals, right? So we could use that language, over equal length input value intervals, output values change at a constant rate. Therefore, P of n is linear, or I could say the sequence is arithmetic. Okay, but since it's written in function notation, it would make sense to say linear function versus arithmetic sequence. Okay. Did anyone find the common difference? What is the common difference? How did you do that? You don't remember? Oh, okay. Well, then tell me what you got for the common difference. -5/3. So, isn't that the slope? And if it's linear, change in y over change in x. Can I go straight there? Okay. Did anyone do it the other way where we started? But there's going to be 3 common differences between 1 and 4 to get me a change of 5. Sorry, -5. When I solve that, I get my common difference. And I ties that into the fact that this is a linear relationship, so we should see a slope. Okay. Any questions on that one? Yes. If you don't have an equal input value interval, you could still check for a common difference this way, where you would go 3D equals -5, and then let's say this one is a width of 2. So then you would have 2D equals whatever that change would be. So you could look from input value to input value and see what is the change between these two, that rate of change, and then do the same thing over this interval that has a different width. But if I have the same rate of change, then it doesn't matter that if they were equal or not. I can look at my rate of change over that interval and see what I get. So I could do it that way. I have not seen any problems put out by AP where they don't, when asking for things like this, don't give equal value input intervals, equal input value, equal length. That's okay. Equal length input value intervals. There we go. Too many words. But if they did, just find the slope between these 2 points, the slope between these 2 points, the slope between those 2 points. Okay. Great question. Any other questions? Okay. My frog problem. If I use a function, how many of you used function notation on this? Okay. And then this would be where this is equal to the number of frogs on the nth night, something like that. Did anyone use sequence notation? Did you use a sub n? Okay, so if you did that, then you would have number of frogs on the nth night. Oops, right? Same thing. It's just different notation. I don't care which one you use. Again, like I said, the reason I used function notation, one, the assignment we chose that came from AP themselves used function notation instead of sequence notation. So I want you to be prepared if on the AP exam you see that. Okay? It's just a function that's going to model it, but we're just using the discrete values for whole number input values. Okay? Then, whichever notation, I know f of 3 is 24 and f of 6 is 192, or I know a sub 3 is 24 or a sub 6 is 192, right? So, how many of you did function notation? How many of you did the sequence notation? Okay, more people did sequence notation, so I'll finish out the problem using that. So now I can write, remember, any sequence. This one is geometric. Did anybody use G sub because it was geometric? Okay, I can do that. I really don't care. Okay. So now I know G sub 6 is going to equal G sub 3 times R to the 6 minus 3. So I get 192 equals 24 times R to the third. Yes. Because when you're writing from a term in the sequence, if you're going to write an nth term, it needs to be in terms of a term prior to it. Because otherwise you're going backwards, and it would be it probably would still work, but in your mind it doesn't make sense to I don't think it would make sense to go from the sixth term backwards to the third. So I choose the latter term versus the previous term. Okay, so now when I divide 192 by 24, please tell me I get 8. Good, because that's how I set it up to make nice numbers. So then R is going to be 2, right? So then my model G sub n, I can start wherever I want. 24 times 2 to the n minus 3. I do not have to go back to an initial value. Is this a legitimate model that's going to find the values. Okay. And if I did put in a number before 3, it's just going to divide by 2 to that power, multiply by 1 over 2 to that power, because it's going to give me a negative exponent, right? So now I want to find out how many there will be on the 10th day, which is going to get me 24 times 2 to the 7th, which is what? Did anybody find 2 to the 7th, or you just plug everything into your calculator? Huh? 128. And now when I multiply this, I should have how many frogs by the end of by the evening? Is that what you said? Okay. And then you're going to give me a sentence, right? By the end of by the 10th night, there should be approximately 372 or about 3,072 frogs in Ms. Burleson's pond. Yay. That's what it sounds like. It's what it sounds like. Okay. So, does that make sense? Okay. What I was going to do after forecasting last time was, remember I said the thing on the semi-log that I just went straight and we plugged in the information, and I didn't do something that I should have done, and I want to go back over it. So this, if you go back to the semi-log day we did in class, it says use your knowledge of the log properties to transform this into a linear model and then compare it to the numbers. We just took the numbers from above and wrote the linear equation, and then we plugged it in, the data into the calculator, and saw that we got that regression. But we should go back and review the log processes. So I want to do that really quickly. Oops. And this one is a little hard to read, so I'm going to get the original paper that we used so I can see maybe the numbers. What? Oh my goodness. Okay, it was I will write this nicer. Y sub 1 equals log of 2200 times 1/2 to the t over 6. Okay. So using log properties, the first issue is the t to this t over 6. Is that both of those numbers raised to it? No, just this one. So the first thing we have with log properties is I have a product. If I have a product inside my logarithm, what can I do? If I have multiplication, if I have multiplication inside my log, what can I do? I can write this as addition of the two, because when I multiply with like bases, I'm adding my exponents. Logs are exponents. So this will become log of 2200 plus log of 1/2 to the t over 6. Didn't I use a log property to do that? And then, do I know another log property that I can use? I should probably write that a little better, like it's an exponent. Make it clear. T over 6. There we go. What can I do with an exponent inside the log? Multiply my exponents. Oh my gosh. So that exponent can come out front, right? So I now have log of 2200 plus t over 6 times the log of 1/2. What the? There we go. Log of 1/2. Which means I have log of 2200 plus dividing by 6 is a number. Log of 1/2 is a number. Do you agree with that? So I have log of 1/2 all over 6 times t. I dropped a 0. I did. Yep. Wink. Here we go. Is that what you're going to tell me, Wyatt? Thank you. So if I'm not mistaken, y1, this looks like a slope and a y-intercept. You see that I've converted it into linear. We might need to know that. Not on the in class. Caitlin.
Why is the T outside?
Because basically what I did, let's just look at that. I have t over 6 times the log of 1/2, right? This is just t times 1 over 6 times the log of 1/2, right? Because t over 6 is t multiplied by 1/6, right? Just like if I have 2/3, technically, isn't that 2 times 1/3, right? Okay. So this is a number and this is a number. So can't I multiply those together? So when I multiply those together, I'm going to get log of 1/2 over 6. And then I multiply that by the t. And I just, to put it in a form that makes it look like it's linear, we usually have the variable behind the number. That's why. Because this division is an operation with a number. And we can do that. You guys do that when you were learning order of operations. If it's easier to divide into the second number than the first number, you do that, right? So that's just the same thing here. Does that help? Any other questions? Okay. So,